10, which of the following nuclei lie within the band of stability? And then we have 205 TL. Okay, so we have thallium. So, in order to find out whether this is a stable or an unstable isotope, we have to find out whether it's going to be in the band of stability. Now, the band of stability is the blue over here. All the green is all unstable radioactive molecules, but those do not, those are not within the band of stability. Only the stable blue lines are within the band of stability. Now, in order to find this out, we have to find out the total number of protons and neutrons that the isotope has. Now, I see that we have a top number of 205. The top number on this nuclide notation is always the atomic mass. And the atomic mass is always the total number of protons plus the neutrons. So it tells us the collective whole as to how many protons and neutrons we have, but I do not know how many are protons and how many are neutrons. Now, if we do see this notation, generally there is a number at the bottom as well. And that number is your atomic number. And the atomic number, going all the way back to the beginning of chem, the atomic number is always just the number of protons. So, let's find out the total number of protons. How do we find that out? Well, we got to go to the periodic table. All atomic numbers or all protons are unique and different to each element. So there will be no two elements that have the same atomic number. I look on my periodic table, which is right in front of me, and I see that the atomic number for thallium is 81. So we have 81 protons. Okay, well, how many neutrons do we have? What do we have to do with these two numbers to get the total number of neutrons? Yeah, we have to subtract. Because if the atomic mass is protons plus the neutrons, and the atomic number is just the protons, we can subtract to find out how many neutrons we have. So, let's see. 20 minus 8 is 12. 5 minus 1 is 4, so 124. And if I just add these up, let's see. 4 plus 1 is 5. 2 plus 8 is 10. So this is this? Yes, 124, right? Yeah. 8 plus 2. Yeah, 8 plus 2 is, yes. 8 plus 2 is 10. Bring the 1 over. Here's the other one. So yeah, that's a 2. Okay. So we got 124 neutrons. Now, the first thing you want to check is to just see if you have any magic numbers. There are 7 magic numbers that make an atom more stable than it usually would be. But out of the 7 magic numbers, I don't see an 81 and I don't see a 124, which means that I have to go to the actual graph. And this is based off of protons versus neutrons. So all we have to do is find out 81 protons and see if there's a blue line with 124 neutrons. So let's see. I'll probably, let's see, maybe it would actually be easier to get that 124 because it's an even number. So let's see, if I go over here for 120, I'm assuming that's this line right here. And this is a big jump. So I would probably say that this has to be the 81 here, right? 124. This is 124, and then there's like a little tick here. And that kind of goes by with the 180. Here's 180. So right next door has to be the 81. And it goes with the big jump of being 124. So I would say that this actually checks out. And if I want to draw them again, here's the line that goes all the way down to 81. And then over here, it's going to straighten out. And then I can just make it work. There we go. And then this one. Yeah. And that looks like it makes good work here. So I would say that this is a yes. You are within the blue region. And if you are in the blue region, you are a stable isotope and you're part of the band of stability. So I hope that helps. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you in more questions. We also have memberships on the channel if you want to become a member. Thank you if you're going to do that. And I'll talk to you soon, okay? Have a great day. Bye-bye.